Started. Just 1 minute. Takes some time to set up. All right, go ahead.
Hello everyone, I'm Thilak and Surendra Babu from Nutanix. I'm here to talk about better exception path for OVS-DPDK. So I'll start with the problem statement. So when you move your data plane from kernel space to user space, there are applications which actually make use of the kernel TCP IP stack. And when we moved to DPDK, we figured out that the performance for those applications were actually dropping. And the reason for that is that the VR0 interface is actually used by the it's handled by the non-pmd thread, and that's the vSwitchd main thread. And so the most natural thought process was, hey, why not we try virtio-user as an exception path and see how the performance improves. So the virtio-user as an exception path could be added as a DPDK dev args, but when we added it as a plain old DPDK dev args, we understood that the packets that it was moving was not coalesced. So basically there were small packets moving over the vSwitch thread, and because of that, the vSwitch thread was predominantly at 100% CPU, and it was moving larger packets, and as a result of that, the application was also suffering in performance. Now, the most natural thing is to kind of try to see if you could enable GRO and TSO offloads, but the challenge with that is that the OVS-DPDK doesn't deal with multi-segmented MBUFs. So how do we solve this? So what we ended up doing was, for the virtio-user as such, we used the mergeable RX buffers, and right on the RX side, right after we receive the packet from the virtio RX rings, we try to allocate an external MBUF and then copy these small segmented MBUFs into one single humongous extended MBUF, and then send it across our OVS-DPDK packet processor. On the TX side, right after we receive the packets from the Ethernet interface, we try to make use of the RT-GRO API provided by the DPDK and chain these MBUFs such that you create a humongous packet, but it is a segmented MBUF. Now, enqueuing this into the TX is still supported because anyway we are using the mergeable RX buffers, and with that, I'm going to show you the results. Now, the one with the master is where we see that the vSwitch thread was at 100% CPU, and the performance was also at 6 gig and 8 gig in each of these directions. And the PMD thread CPU usage is what I'm showing here. There you could see that I'm showing I have two PMD threads. One PMD thread handles the virtio-user, and the other PMD thread handles the physical Ethernet interface. Now, with my changes, I could see that the vSwitch CPU actually reduced significantly, and the bandwidth also increased. That is because the TAP interface, which is backed by the virtio-user interface, started handling TCP frames of TCP segments of 65K byte size. So on the PMD CPU usage, in one direction, that is a packet towards the virtio-user. In that direction, we saw that it was at 90% CPU usage, but I think that is mainly because of the kind of the GRO API that I was using. I was using the bare bones GRO burst APIs, but maybe if I use the GRO API with the context, maybe I'll get better performance out of it. And the other direction is where I actually do a copy. But in that, the CPU usage actually decreased. I think that is because the copy itself was done by AVX instructions, and the OVS-DPDK is now handling fewer packets than what it was doing before. So that's pretty much I have for this topic. I have the code in a format. I'll kind of like work it in a way that I'm comfortable enough of posting it, and then I'll post it. The other approaches that I would look for is like, hey, why not we use AFXDP And if you use AFXDP, probably we wouldn't even have the need for the VSNet thread. But again, I think that probably needs the newer kernel. Yeah, that's pretty much I have.
All right, thank you, Thilak, so much. All right, we're a little bit early on time. If anybody has any questions, I guess we have plenty of time. Does anybody in the room have any questions? Going once? Going twice? Going forth? Okay, I think I skipped the number. No questions. We'll check virtually if anybody has a question. If not, do we have any? No questions. Yes, there is a 30-second delay. I guess we do not have any questions. So next is gonna be a little bit of a break. Check your legs. The leg is gonna go until 2:20, I believe. The schedule is online, so you can see. Yes, 2:20. If you want to go ahead, there's some snacks outside. You can get some drinks. We'll be back for the next talk with him as well. All right, thank you so much.